Hi, we're back. In this segment, I'd like to finish the project and do parts E and F, the summary stats, and the confidence interval for the mean. Now, you have to choose a quantitative variable to work with. In my case, I'm going to choose the variable average. With my questions, average is a true quantitative variable. My other variable is really a categorical variable because these are really categories, and even though I can associate a number with those categories, it doesn't have a level of measurement where means and standard deviations make so much sense. So since that's kind of intrinsically problematic when you have these kinds of categories, I'm going to avoid working with that variable for now and just work with the the average number of texts per day as my variable. Okay, so that variable is here, and we did in class the summary statistics for that variable, which I have on my sheet, and I copied and pasted it into my Word document. If for some reason you don't remember how to do that, if you go to the select the data tab, and under the data tab select data analysis, then this is under descriptive statistics. If you select that, then the input range is where the data resides on the spreadsheet, so you'd have to select the data, put that syntax here. Label in first row is whether or not your first row is text. And the output range, the output options, you could put the output to this worksheet. You could select a cell where you would want the output to start, or you could put it on a different sheet. But you would want to for sure select summary statistics. So I don't need to do that because I've already done it. And I think it might be in your syllabus. I think it is. It's in your syllabus also how to go through the descriptive statistics. So anyway, either you did it in class or you look in, you refer to the syllabus, you can get the summary statistics for the variable of interest. And so once you've done that, we want to make some plots for this variable. So to do some plotting, I'm going to select the variable, then select the values for the variable. So I have everything selected here. And then I'm going to go to Insert, and there's lots of charts, right? Now this is the newest version of Excel, and if you're using 7, I think this is 2010, if you're using 7 or earlier, it will look different. But if you select a chart, see here I can have recommended charts, which is kind of nice. And this is also new. There's actually some new things in Excel 10 that was not available in earlier versions of Excel, like the histogram, for example. There is a default histogram chart available in Excel now that was not available in earlier versions of Excel. And this is obviously it's very convenient. To get a histogram in Excel, I don't want to go through the details here, but it is in the syllabus, and I guess I could confirm that by looking in my syllabus, which is here. So if I look at that, here it is. So I think okay, here's the descriptive statistics lab in Excel, so all the details are there. And then here's how to make a histogram in Excel. So if you don't have 2010, you can follow these details for how to make a histogram in Excel. But the details are here how to do that. If I was going to consider making a separate video on that or make a separate video available, I'll consider it. But for now, I'm going to ignore that because I don't need to use it. Okay, so here I have this default histogram, which is sort of okay in terms of the shape of the data. But as you can see, these numbers are pretty bad. I mean, I don't want all these digits, and clearly it's taking up way too much space in the plot. So before I can use this, I would want to change some formatting here So if I right click and format the cells, I want the numbers, I'm just going to round to, the nearest one. These numbers were generated from the random number generator using a normal distribution, and so I have lots of digits here, but the digits are meaningless. The average number of texts per day, our respondent's going to give an integer value, probably not a fractional value. So I'm going to keep the number of decimal places to 0 and round them all. So now that they're rounded, if I once again go to insert and I look at the recommended charts, I am keen on using the this chart, and that's kind of nice. And so now that I have that chart, I do want to provide oh, I have the title. No, I want some axis labels. So where do I find those? So I have to find them. Okay, I have a title. I want an axis label, and I want titles. So I want a title there, and where did I get this? Oh, actually, I might be able to, no, it wasn't there. Okay, and I want the other axis title. Okay, so now I have everything. So this is the number of text messages. That's what this axis is, actually. And we could just call this number of daily text messages. And this is, I'm going to call this texting habits of college students. Probably underestimates the true values. And this is frequency. Okay, so here's my histogram, and which is kind of nice. So that's a new feature in Excel, very new. And so if you copy that, you can paste it. You can paste it in the Word document here. Okay, so I guess I don't really need to resize it so much. It's pretty reasonable. So there it is. And so I've identified the variable I'm working with, and I have now the summary. I have the histogram. In the histogram, I have title, axis, and axis labels. And what was the other thing we wanted here? A box plot. It used to be that Excel did not do box plots, and if you're working with an older version of Excel, you can actually do that. In this version of Excel in 2010, not sure if you can do it or not. I don't usually use this version. So let's look at all charts. Did I see box plot? I see box and whisker plot, so that's what I'm talking about. So there it is. So if you have 2010, you can do that. And that might be available in the library, come to think of it. So, because my computer in my office has 2010. So I think you could do this in the library. So I still want to select that. Did I get rid of my other chart? I guess I did. See, I'm a little bit, I just want to snag this title. And so here's the title. And whoa, font size way too big, problem. So if I go home, I can fix that font size and change it back to something that's a little bit more reasonable. Hello, let's I'm trying to select that. Okay, so 12 is good, and then I have the box plot as well. And so of course, you know, I would want to have, you know, an interpretive statement for the charts. So I have the you know, this looks roughly normal, which makes sense because it was generated from normal data. It looks roughly bell-shaped. And in terms of the box plot, for bell-shaped data with a box plot, you're looking for symmetry. So this is somewhat symmetric. I mean, it would appear that this, let's see, this is the first quartile. Here's the second quartile. Here's the third quartile. The third quartile looks like it's a little bit bigger than this, you know, the inner quartile range. It doesn't look like it's, you know, exactly in half. It looks like it's a little skewed. But there is symmetry here. So I'm going to say that it's, you know, roughly symmetric, roughly bell-shaped. Oh, and I should have put on, an axis label here. And so, or just delete this because it's a little silly having the one there. Well, that's a little detail. I'll have to fix that later. I want to get on to the confidence interval calculation for the mean. So we do need to calculate a margin of error. And again, I'm going to identify what the random variable is here. So the random variable is, you know, the number of text messages sent. So I want to be very specific about what I'm calculating. And then, so I'm going to get rid of this. I don't really need it anymore. Well, actually I do because I want to fix it up. I'll put it over here. Okay, so to do this calculation, what do I need? I need a t value, right? The critical value for t. So I'm going to call this T05. Okay, so what's T05? So to calculate T05, I'm going to put an equal to here, and I'm going to look for that function. There must be a T inverse function. There's just got to be. So to find that, I'm going to look under f of x and statistical function, and if I look under t, let's see, there's the t distribution, and here's t inverse. So under t inverse, I have to identify probability, comma, degrees of freedom. So that's the one I want. So the probability is, well, what did we, you know, I just realized, for this, the probability, you know, I put 0.05 for the proportion. I used 0.05 for the proportion, that value, but that was incorrect. I should have used 0.025. So I don't really want to remake that video at this time. Okay, the probability should be 0.05 over 2 because it's a confidence interval estimate, so it should be 0.025. And the degrees of freedom here is 99. It's at -1. So if I click OK on that, I have that. And now, like, you know, I have a problem because it's negative. I want it to be positive. So again, I can use absolute. So if I use absolute value on that, then that will force it to be positive. So there's the positive value. So now when I'm calculating E is going to be, what do I need? E is going to be equal to my T value, right, which is T alpha over 2, times the standard deviation. So the standard deviation is here. And then I need to divide that by the square root of n. Now I happen to know, since n is 100, the square root of 100 is 10. But if you didn't know that, or if you had a sort of unusual value you were working with, you could just put in the square root and then put parentheses and put your n value, and it would, you know, find the square root that you need. So there's my margin of error. So now that I have my margin of error, I can do a lower bound and I can do an upper bound. Okay, so here my margin of error is about 0.8376. I'm just giving 4 digits. And I copied my math from, you know, I pulled this from another document. So now I'm going to calculate the, in fact I can center justify this stuff, it'll look a little nicer. The confidence interval estimate is here, so I'm going to put, did I take, I called something called like math symbols. I can put this on Campus Cruiser if you're interested in using this. So if I do a copy, then you know, I can paste that here and put my math symbols, you know, in either direction, and one here as well. Okay, so my lower bound, what's the lower bound? So the lower bound is going to be equal to the mean minus the margin of error, and the upper bound will be equal to the mean and then plus the margin of error. Okay, so that's what it is. So we have, oh, so not really so interesting, because the standard deviation here is, I guess, pretty small. I just want to check this a minute. So it's okay, yeah, so that's reasonable. Okay, so this is, if I give one additional decimal place, it would be 19.7, and this one would be 21.4. So I think I'm going to get rid of this. And then I would give an interpretive statement, you know, average number of texts today, texts per day for college students would be between, say, 20 and 21. So on that order of magnitude. Okay, so that's it for part 2 of the project.